Hey kids, Smath here. Today's lesson, concentration of solutions. Now we're going to learn a couple of different forms of concentrations in this video. This one's going to be really short, just going to define what the terms mean. And then the next video, we're going to go through a series of examples. We have more than our normal 2 examples of each type. So the first type of concentration we have is called molarity. You guys have heard this term before. This is going to have a symbol of a capital M, and it's often going to have a line underneath it so that we don't confuse that with molar mass or the SI unit mega prefix, megabytes. So we're going to try to use that line underneath there. And molarity is simply the moles of solute per liters of solution. I'm just going to caution real quick, be careful. That's liters of solution, not liters of just the solvent, but the liters of the combined thing of everything put together there. So that's our molarities. And that's the most commonly used bench measure of concentration. Now, the next one we use is called molality. And notice I went to a lowercase m here, and this is going to be an M, and quite often this is going to be a lowercase m that's italicized. Now, I'm sorry, I can't write in italics, but imagine it's a lowercase m, and this one takes a little bit different feel. This is the same moles of solute, but now instead of liters of solution, we're going to do kilograms of just the solvent. Now you're thinking, why do we need 2 different measures here? Molarity is the bench standard of what most normal chemists are going to use. Molality we use when we do what are called colligative prop calcs. And we'll do those in a series of videos further on down the road. But that's why we need molality. We need to know what's the mass of solvent, not just what's the total volume of stuff. So we have that. The third measure of concentration we have is called mole fraction. Now this relates to partial pressure actually. What we find out is partial pressure would be the pressure of one gas over the total pressure. Well, where does pressure come from? The number of particles. Well, then the number of particles would simply be that. It would be the mole fraction. So in this case, what we have is the moles of A over the total moles. This is going to be a decimal. I know you guys are saying, Smath, it's called mole fraction. Why do we have to make it a decimal? Because that's how mole fractions are basically determined. They're a lot like batting averages in baseball, that we're going to make it a decimal with 3 digits after it. That's just very common for mole fraction. Here's the beauty. Mole fractions must add up to 1. Because if we're looking at the percentage of something and something else in the total, all the percentages have to add up. So hopefully you're hearing a little bit of Dalton's law of partial pressure in this explanation of mole fraction. Now our last measure of concentration that we have is the cheap and easy mass percent. This is going to be the grams of one substance over the total grams. Obviously, it's a percent, multiply it by 100, and in this case, let's carry to the 10th of a percent on these. That's a good level of accuracy for us. So what we have are 3 different measures of concentration, each having their own use. Molality getting used with colligative properties. Mole fraction being used quite often with Dalton's law and partial pressure. Mass percent is used commonly on industrial purposes, where we're just going to take a scoop of a sample out and find out what mass of our sample, of the total sample, is just the part we're looking for. That's a very cheap, easy to do calculation that can be done out in the woods, out in the field, out on the industrial floor. And then on the research side of things, we're going to use molarity for our measure of concentration there. As I say, these are all just definitions. We've defined what the terms are. The next video is going to take you through several different examples. I'm Smath. I hope this video helped.